In the shop today we have a 2001 Volkswagen Beetle 1.9 liter diesel TDI with a 01M transmission, and its transmission's going to limp mode. Let's see what codes we have. Okay, we scan the transmission. Guess it'll help if I turn the car on. And we go to fault codes, and we have a solenoid code 00264 for solenoid N91. It would probably be simple enough just to go in and change the solenoid as a first step, but we kind of want to know for sure because the customer's expecting us to diagnose it properly. So if we put a solenoid on it that doesn't fix it, they're not going to be real happy. You can resistance check these, but I prefer to amp test them because it's a more sure way of testing it. It's going to show. That's the solenoid connector right there. We'll need to pull cosmetic cover and the breather out in order to gain some access to do some amp testing. Bolt and the rubber grommet was missing. Should look like this one. Now as I look at this, I can see that the latch around this connector is missing, so it just nice and easy unplugs and plugs back in. We find a lot of them this way, and usually it's okay, but there have been a couple times where that latch being missing keeps it from staying plugged in good enough, and it wiggles around and triggers various codes. That might even be the problem on this car. It's very hard to determine if that's the problem other than putting a new latch on it and driving the car. I might have a latch. I should have bunches because we do a lot of 5-speed conversions, but that's not really a part that we save very often. But I might have one on a parts car, I think. So I'm going to go ahead and amp test this, and I'll put one on it. Now if you visit my website, it shows this connector and which ones are which to which solenoid. So you can go in there and you can specifically, using that information, you can go in there and you can specifically amp check the one solenoid that's the problem. The only problem with that is it's very tight in there. It's very hard to get an alligator clip on there just on the one solenoid, but I've got a way around that since I do this all the time. And here's what I use to amp check O&M solenoids. You can do it with alligator clips, but like I said, it's tight in there. So what all this is an O&M harness that I've cut off the car. Plugs right into the transmission. The wires are already stripped, and I have with it notes on what wire color in that harness goes to which solenoid. So I have a trouble code for the N91 solenoid. So as I'm looking at my notes, it shows that the blue with a white wire goes to the N91 solenoid. So that's there's more than one blue wire. The blue with the white one right there. And of course, to do an amp check, you need 2 wires. And all the shift solenoids are powered by one common wire. And on my notes here it says the B plus is black. So we'll amp check from this wire to this wire, and that should give us an amp reading for our N91 solenoid. Okay, so we plug in here and back out a little bit, and then we hook our power to the black wire. Now, an 01M solenoid doesn't have a diode in it. Other solenoids do, like other transmissions, Ford, Chevy, Chrysler, Toyota might have a solenoid in it. So if you're going to amp check a solenoid on a different make, you need to make sure that it doesn't have a diode in it, or make sure that you're amp checking it the correct polarity. If you hook it up backwards, you will fry the diode. So I'm looking for my blue with the white trace, and that's this one. So black wire, and this blue one with a white trace, the computer provides it a ground to turn it on. So it's provided power all the time through this black one, and some of the other solenoids are powered with the same black wire, and then when the computer wants it on, it grounds this. Before I hook my amp clamp to the meter, I'm going to go ahead and ohm check the solenoid. There's my meter. Got it turned to resistance. Probably can't see it there, and I'm going to hook the clamp to there, touch right here, and it has 5.1 ohms. The resistance spec on that is 4.5 to 5.1 ohms, so the resistance is in spec. Let's see how it amp checks. Okay, to do the amp checks, we plug in our meter here, or we plug in our amp clamp to our meter here, clamp it around any of our wires. Notice we have a reading on the meter, so we zero that there. Hook up some voltage here. Since we have it on the 1 millivolt equals 10 milliamp scale, we move the decimal point one place. And since it's showing 0.2 volts, well, it's actually showing negative 0.2 volts, so we need to flip this meter, or this around here, or we can just ignore the negative sign. I'm going to zero that again, and so since it's showing 0.2 volts, that means we have 2 amps flowing, and we'll have to do some math to see if that's correct, and I'll show you that here in just a second. Okay, Ohm's law expresses a relationship between resistance, amperage, and voltage, and in order to calculate how much amperage the solenoid should flow, we just plug in our specification for the resistance of the solenoid, which was 4.5 to 5.1 ohms. So we put the 4.5 here in for the resistance. And our voltage on the car was 11.5. And we do a little high school algebra here, so we divide both sides by the same thing. 4.5, that cancels this out, and then we have amps equals 11.5 divided by 4.5, and when you're dividing two decimals, and you can move this over like that, and so 2 times 45 is 90. and that leaves 5 and 2, 5. You can drop down a hypothetical 0 and put the decimal point there. And 45 goes into 250 5 times. 5 times 5 is 25. 22. The remainder of 25. So if you drop down another hypothetical 0, that 5 will just continue out. We're supposed to put a line there. So the most amperage this solenoid would draw would be 2.5 amps. And in order to calculate the least amperage it should draw, you drop that 5.1 into our calculation, into our formula. The same 11.5, and divide both sides by the same thing, and that cancels out, so amps equals 11.5 divided by 5.1, move the decimal points over. 51 and 115 is 2, making 102, and that makes through 13, and then we drop down a hypothetical 0, put a decimal point there, and 51 goes into 130 2 times once again, making 102, leaving 28, another hypothetical 0. But one decimal place is accurate enough for what we're doing, so I'm just going to stop here. So the least amperage this thing should draw would be 2.2 amps, and that is exactly what we had. So the solenoid amp tests just fine right now. Okay, so we ohm checked and it tested fine, and we amp checked and it tested fine. So the question is the problem happening right now? So I know when I drove it in the bay that it was in limp mode. When I accelerated to drive it forward, it was very, very sluggish because the car was taken off in a higher gear. That's what happens when it's in limp mode. But I never did check to see if the code reoccurred. And so let me turn the key on, and we'll clear the codes and see if it reoccurs, seeing if the problem with the solenoid circuit is happening right now. Fault codes. Code is there. I'm going to clear it. Check again. And no trouble codes. Certain solenoid trouble codes will only trigger if the computer is using that solenoid right now. So if the solenoid isn't on right now, and I believe the N91 is the torque converter clutch solenoid, obviously the computer isn't commanding the torque converter clutch solenoid on right now, so it might not reoccur. So let's go ahead and start it and see if it reoccurs. And it probably won't, because the computer isn't going to command that solenoid on sitting here at an idle. It's only going to turn that solenoid on driving down the road, so that's probably when the code would reoccur. So I'm not surprised the code isn't reoccurring here, but that's obviously going to make it difficult to diagnose. We got to catch it when the code reoccurs in order to do any type of ohm testing, because that's when the computer's noticing the problem. So I guess I'm going to have to drive the car. Okay, I'm really in a hurry. I just got back from the road test, and the limp mode did reoccur. So I'm assuming the solenoid code reoccurred, and sometimes you only have a narrow window to check it and have it still show the problem. Now, I don't mean the trouble code. There is the trouble code. It did reoccur, same trouble code. And I took it out and I got the torque converter clutch to apply several times. It did take me about 10 minutes worth of driving before it reoccurred. So let's get out there and amp test it quickly so that maybe we can check, identify the problem. I didn't put the bolts in the breather on purpose so I could get this out quickly. Okay, alligator clips are still hooked up. Give me some voltage and put the amp clamp on 1 millivolt equals 10 milliamps, and clamp it and provide a ground. This time I'm getting no amperage flow. Make sure I didn't make any mistakes here. Up. And for giggles, let's do a resistance check. And I'm getting an open resistance. Oh, I never turned it to resistance. And I'm getting open circuit when I check resistance. Now we can check some of the other solenoids to see if they're flowing, if their resistance is okay. That one has 72. That one has 71. 72. 75. So all the others are working. The resistance check is fine, but here's our problem circuit right there. No amp. Open circuit. So this doesn't conclusively tell us it's the solenoid because we are testing through the internal harness of the transmission. That means we'll need to pull the pan and resistance check the solenoid, or amp check the solenoid with the pan off, eliminating the internal harness as a potential suspect. The only problem is this thing only tends to fail when it's warmed up. You know, the engine's nice and warm now that I drove it for 10 or 15 minutes, and I think the solenoid's only going to show failure when it's warm and flowing amperage. So maybe when we get the pan off, it might work fine. I have seen that before. Hopefully that won't be the case for this example video, but we'll pull the pan and see if that's the problem. And of course I'm in a hurry in order to get this pan off, and I realize it's got a skid plate on it. Pressing. cleaned out bucket here because this customer just replaced the transmission fluid and filter, hoping to fix this problem. So we're going to be reusing it on this job. What I just removed is what I would call the fill or check plug, or fill check plug. And then now what I'm removing is the stand pipe, which is just a little pipe that stands up in there to set the fluid level with. And of course, I don't know if you can see that in the video, but this is red fluid. There is nothing wrong with putting red fluid in an 01M as long as it's compatible. Always take a look inside the pan for any debris like touch material or metal material. This one looks good. Of course it would, since the pan's just been off. Hopefully they cleaned it out. You'd want to break open the filter also, but I'm not going to do that since this filter's brand new. Any material would have been trapped inside the old filter anyway. Now nothing holds this filter up in here except the pan itself. These little bumps here is what sits on top of the pan to hold that up there. So I get tech help calls and emails that say things like, when I pulled the filter off, it was just sitting in the pan. That isn't the case. When you pulled the pan off, the filter fell into the pan. Now that may mean the seal is pretty worn out, because as you've seen, this one was nice and new and it stayed up in there, but it doesn't mean your filter was sitting in the pan. Now the N91 solenoid is the TCC solenoid, which is the fifth one back in the row of 5. There's 5 of them in a row and 2 of them in a row. So the fifth one back in the row of 5. So the solenoid harness is made out of plastic, and it does break sometimes when you unplug it. You have to be very careful. They sell a special tool. You can get this tool from my website. It's a 3373 tool, www.kansascitytdi.com. And the way you use it, probably need to change camera angle for this, but you stick it in there and you give a little pry, and if you are really gentle and your harness isn't extremely deteriorated, you can get it out without breaking it. If you improvise, you might not. You get a different angle where you can see it. Okay, to remove the solenoid, you take the 3373 tool and you put it in here, and you use gentle pressure that way, and a little twisting motion doesn't hurt either. And see that unplugged nice? Come around to my side some. If you look at the top of that, it's not broken. If it did break, the broken pieces would stay up inside the solenoid. Okay, I'm going to ohm check this solenoid. It's easy to ohm check. It's hard to do and get it in camera to where it's visually visually everything's in the picture and you can see it. So the way I've set up the meters on resistance, I have it beeping for continuity check, so when I touch the terminals together it beeps. So if I ohm check this solenoid, it should beep and show an ohm reading. Okay, this may beep if I bump the 2 leads together as I'm trying to do this, but when I get it hooked up, it should be beeping and there should be an ohm reading, and there is not. I'm connected right now, and I don't know if you can see the meter or not, but the meter is showing off limits, which is infinite resistance, or the same resistance that air would have. And I'm touching the terminals pretty securely. Obviously we have a bad solenoid. And this deal's getting in my way. This is an aftermarket one. I don't really like. I like the aluminum skid plates because they protect it. The plastic ones work just fine for what they do. I don't know why I'm doing this by hand. I better go get a tool. ID tag for the valve bodies right here. This one is a QFB. I just loosened that and folded the bracket down out of the way, like that, because this last one here is a little bit hard to get to. It's blocked by this spring detent roller. So if you're just changing one solenoid, you can fold it down out of the way and do it. And with now this solenoid will simply pull out. There's a new solenoid, and if you need a new solenoid, you can order that from my website, www.kansascitytdi.com. New solenoid in, plugged in, bolt the bracket back up. Okay, if you took this bracket all the way off, it does have to go on the right direction. It can go on upside down, and that would make it not work right. There are springs built into the bracket that push downwards on the solenoid, and I have to hold that solenoid inwards in order for it to seal against the valve body. So if you installed it upside down, the springs would be pushing up, not pushing the solenoids against the valve body, so they wouldn't seal and they'd leak off the solenoid feed pressure. But it'd kind of take a big dummy to do that. But I'm sure people have. Okay, so we put the filter in. We make sure that the pan gasket has these spacers inside of it. If they don't have those spacers, it's going to leak. Also, as you bolt it up, the pan gasket sometimes wants to fold inwards like that. So after you get it bolted up, or as you're bolting it up, watch it. Make sure this surface right here is parallel with the ground. Don't let it fold upwards. Even if it's folded upwards just a little like that, you'll end up with a leak. I'm not going to video putting the pan back up. So here's a connector that I have in order to replace the lock mechanism on this Beetle. In order to get it off, we'll have to release that tab there, release that tab there, and it'll slide off. But to unplug these, it's like a medicine bottle. You squeeze it right here, and that allows, it flexes it outwards to where it unplugs. The only problem is the output speed sensor connector's in the way. You can't see. Give me just a second. The only problem is the output speed sensor's in the way, so your thumb can't get on the portion of it that you need to push on. So in order to do this, you unplug the output speed sensor and push the connector right there forward. I can't get it to move easily, and I'm not going to do it here just to show you, but you move that forward there, it sits in a groove and it will come out of that slot, and then you can get your thumb on it in order to remove it. Now if it's really a struggle, you can go ahead and release these and take it off there, that's how this one probably ended up the way it is. Somebody took it off that way and didn't put it back on. But we'll make it right. So there it is, all fixed up nice. We'll get a nice solid click as we put it on now. Good to go. And plug in the output speed sensor. Not going to show the breather and all that, but we'll recap once we've test driven it, make sure it's right. I did want to show this as we took it apart. The second one was missing right here. And when you come to a Volkswagen specialty shop, the benefit of coming to us rather than your Joe average mechanic, or in this situation maybe a transmission shop that would attempt this repair, is that I have the missing bolt and the missing grommet to put in there. Do I charge them for this? Nah, I just rounded it up off a used parts car and just throw it in there. Don't have to charge for every little thing, but makes a much nicer repair. And while we're at it, fixing things for free on this breather, there should be a rubber ring installed here, and it's sitting right here. That is the part it goes on, but it doesn't really seal right if it's stuck there, because it just pushes it backwards. It needs to be here and installed in there where it goes. Alright, that looks better, and that'll seal up better, make sure no contaminants get into his engine. Okay, I just finished road testing this Beetle after we replaced the torque converter clutch solenoid for a solenoid related trouble code, and it did fix the problem. No more limp mode, code didn't reoccur, transmission works great. This is a 189,000 mile vehicle, and I think it had a used transmission put in it at one point, but this transmission works fantastic for this car's age. One of the difficulties in diagnosing this car was that the car would work okay for a while and then the problem would happen. So the car would be drivable, work good, code would reoccur, and then it would go to limp mode. If you cleared the code the next day and drove it, it would work good for a while and then the code would reoccur. So along the same lines as that, if you tested it first thing without driving the car till it acted up, if you tested it, it would test good with amp check and with resistance checks. So I really think if I would have amp tested it longer, and maybe I'll do that with the bad solenoid on the workbench, if I'd have amp tested it longer, more repeatedly, more times, got the solenoid hotter, maybe then it would fail and fail the test. And that's why I think amp checks are better than resistance tests, because it puts it in a working condition, whereas resistance checks doesn't make the solenoid work, it just checks the resistance of the solenoid. Whereas an amp test makes the solenoid actually do the job that it's supposed to do, flows the amperage through it. Now, I might comment more as I'm amp testing the solenoid, but this is a fixed car. I do have to comment that maybe in this situation it might have been quicker and better just to put a solenoid in it and throw it out the door. As some mechanics would say, fire the parts cannon at it. Just throw the part in and fix it. Maybe in this situation that would have been better. It certainly would have been faster, because it took me a while to do the amp testing and get the problem to act up, and so if I'd have just brought it in, found the code, put the solenoid on it, shipped the car, maybe that would have been quicker and easier. But in the circumstances where it's the internal harness or the external harness or the connector where it plugs into the transmission, if those things are causing it, or even the transmission computer itself was causing it, then you'd have a misdiagnosis on your hand, an unhappy customer. So I think we handled it the best route possible. I want to show a couple other things on the video, such as stroking the valve. I'm going to use a valve body that I have on the bench and stroke the valve on the bench and show you that, because I couldn't really get a close-up with it in the car, and lighting was terrible. I don't think I could have done a good job of that with it in the car. And then I also want to show amp testing the solenoid on the workbench. But if you've enjoyed these videos, give me a like and a subscribe, and be sure and visit my website at www.kansascitytdi.com. Okay, I wanted to show a little bit better the process of actually changing the solenoid, and I wanted to show stroking this valve. So I'm going to use this valve body that I have on the workbench here that's getting ready to be rebuilt, and we'll take this plate off. I'm going to go ahead and leave that one in just like I did in the one in the car, and take these 5 out, and I'll rotate it around so I can get this out. As I was saying on the one with the car, don't unplug the other ones if you don't have to. You risk breaking the harness. So here we go. Okay, inside there you can see the valve and a sleeve, and what you want to do to check this valve is just stroke it up and down. It has a spring. There's actually 2 valves in there. It has a spring behind the second valve, so this valve pushes against the first valve, and the spring pushes it back up. If it doesn't behave that way, then you have a problem. Now don't get super aggressive with it. When you finish, this sleeve, see the sleeve can come up and move around in addition to the valve. If you get done with it and that sleeve comes out of position and is upwards, don't count on the solenoid to push it back in. You have to get it seated back in there the way it is now, where it sits flush with the surface of the valve body. So make sure that valve strokes. If that valve does not stroke and return with the spring, then you have a problem. And make sure that the sleeve is seated when you're done. Okay, right here I have the solenoid from the Beetle. This is the solenoid that had failed, and I have the meter hooked to it, and as you can see right now, I ohm check it and I get approximately 5 ohms. That is in spec, that is good. So let's amp check it and see if we can make it fail with amps. Okay, I've changed my meter to voltage and hooked up the low current amp clamp. On a fluke meter, it has an amps setting, and you can run amperage through that meter. You just have to move the lead over to here. I choose never to do that. I never run amperage through my meter because it has a 10 amp fuse inside of it, and that 10 amp fuse is like $15 or something, and when it blows it costs me $15. So I just never run amperage through it. I always use an amp clamp, and that way it's never going to run too much amperage through and blow that fuse. But so I use the amp clamp. It's on a 1 millivolt equals 10 milliamp scale. So that means we move the decimal point one place. Let me zero the meter once again, or zero the amp clamp once again. So we have 0 voltage flowing. And I'm going to try and show the solenoid and the amp reading at the same time, or actually it's a voltage reading that you convert into an amp reading. And on this solenoid, it only has 5 ohms of resistance, so you just want to tap it. You don't want to just run amperage through it full force, because it could burn up the solenoid. The other solenoids that are 55 to 60 ohms of resistance, you can just turn those on and off and not have to worry about burning them up. Once again, this solenoid does not have a diode in it, so you don't have to worry about polarity too much. So when we touch this ground, when we ground this solenoid, it will click the solenoid on and it'll show amp reading over there. And so the penta will probably move. It might stay in the upwards position, or it might click each time, I don't know. That way. So 2.8, 2.8, 2.7, 2.7, 2.6, 2.6, 2.6. I'm just going to keep clicking this until it acts up. This is a little annoying and hard to hold the camera and do it at the same time. Maybe I'll click it on and off a few times and then come back. So I've been clicking the solenoid on and off for a while, and although amperage has changed a little bit, it's went up. I would say that would be 2.6, and sometimes you can see 2.7 or 2.8 on there. The solenoid's still working, and I feel like it's the amperage draw is correct. So the reason I was doing the amp test is because my theory was the solenoid was failing when it was in use. So when it would draw amperage, it would fail. So a resistance check would be futile in that situation. But now that I've done this for a while, I'm starting to think maybe the solenoid just fails when the transmission warms up to temperature. So I'm going to give a quick test just for research and development. Obviously the car's fixed and down the road. Just for research and development, I'm going to put a heat gun on this and see how long what temperature it fails at. So first of all, I'm going to check the temperature of the solenoid, and it is about 77 degrees, 81 degrees right now. I'm just going to round that to 80 degrees, and then I'm going to throw some heat on it with the heat gun. So I've got the heat gun set up on the high setting and the high and low setting, and I got it pointed over here towards the solenoid, and we'll monitor the temperature on it. And already it's getting up pretty darn hot. I'm going to let it get to 180. That's where the car runs at. Really don't know if I'm getting the temperature of the heat gun or the temperature of the solenoid. Yeah, I'll turn off the heat gun. What temperature do I have now? 130, 150. Alright, now we'll amp test it and see if our solenoid fails the amp test then. Ah, there it just went. The solenoid's no longer moving. It's not stuck. It's just not drawing amperage. It's not even sparking there anymore. It's obviously reached hot enough to where the solenoid goes open. We'll check it with a resistance real quick. And so I touched the two leads together. I have 0 resistance, and the solenoid is reading open now, off limits. Anytime I touch that on accident, it beeps, so solenoid is off limits. So once the solenoid heats up, it goes open and doesn't flow amperage. The computer triggers a code. And the funny part about it is, once it cools down, or at least that's the way it behaved in the car, it starts flowing amperage again. We'll let this thing cool down, and then we'll see if it starts flowing again. Okay, it's been about 20 minutes. I've let this thing cool down quite a bit. It's at 80 degrees. I'll admit I did blow on a little bit with the blow nozzle to cool it down also. But check resistance here, if I can find it. And there's my meter set on resistance. Touch the leads together, it beeps. And once again, we're back to about 5 ohms of resistance. So this solenoid, obviously, when it heats up, it goes open, triggers a trouble code, and then once it cools down, it works fine again. So diagnosing this is a little bit hard. You have to get it warm enough. You have to drive the car and get it warm enough to where the code will reoccur.